Hey guys, today we're going to continue to talk about the trig table and expand that a bit more. Our learning target is you'll be able to use technology to generate slope ratios for new angles in order to solve for the missing side. You know you'll be successful when you can use Desmos to add new triangle ratios to your trig table. Let's jump in and look at a picture that we've seen a few times now. So here is our slope triangle with change in y and change in x, or rise over run like we're used to, as well as this picture where we're starting to think about the sides as opposite, adjacent, and hypotenuse. As we learned last time, the tangent ratio is the same as the slope ratio, and the slope ratio we think about as change in y over change in x. But in this case, for tangent, we're going to think about it as opposite over adjacent. So today we're going to kind of continue talking about it from this mindset. We are really used to this one on the left, and we are now talking about it from a different mindset. So here is one that we've seen before with the 11 degrees, and we already know that the tangent of 11 degrees should be 1/5. So let's actually do it as if we didn't know that fact. We're going to use a calculator. I'm going to pull up a calculator on screen so we can see it together. So here's a good calculator. It's the Scientific Desmos calculator, and I'm going to pull it up over here and kind of make it a little bit smaller so that we can see it the same time. There we go. Okay, so we want to type in this case, not tangent of theta, but I want tangent of 11 degrees. So tangent of 11 degrees. And let me pull that guy back up. Sorry, there we go. Tangent of 11 degrees. So let's see. Here it is, T-A-N, tangent, don't say tan, tangent 11, enter. And it got 0.19. I'm going to use approximately equal to because I'm rounding. And again, we knew that this was going to be what? We said it was going to be about 0.2, and that's really what we got, is approximately 0.2. So more specifically, it's 0.19, da, 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 da. Let's do another one. This one, we already know that the ratio for 18 degrees should be 1/3. So I am guessing that the tangent of 18 should be approximately 1/3, or 0.3 repeating. Let's see what it actually is when we work it out in the calculator. So let me clear this out. Tangent of 18 is 0.3249. So you can see where it's approximately that case. In this case, tangent of 18 is approximately 0.2349. I think I said so, 23, and so on. All right, let's do another one. Here's the 22-degree angle. I know the tangent of 22 should be approximately 2/5, which is 0.4. Let's see what it actually is now. So tangent 22, oh, not 33. Tangent 22 is 0.4040, so 0.4 pretty much. Tangent 22, 0.404 dot dot dot. And then we have one more, which was the 45-degree angle. When we had done this, the ratio was 1/1. So tangent 45, we should think should be about 1. And let's see what it is here. So let me clear out again. Tangent 45 is exactly 1, matter of fact. All right, so we're getting kind of used to how to use the tangent button in the calculator. Let's try some more for this one. It says, according to the triangle at the right, or below I should say, what is the slope for the ratio 32 degrees? So this is kind of turned a little bit, and I want to start by noticing that we should probably label our sides. Let's start with hypotenuse. That's across from the right angle. So here's my hypotenuse. Next, I'm going to measure across from my reference angle, which they're telling me we're using 32. So I'm going to circle it. It's my reference angle. Across from that is my opposite side. And then the last one is adjacent. It's next to 32 degrees. ADJ. I'm going to use that. So opposite, adjacent, and hypotenuse. And we are looking for the slope ratio of 32, also known as the tangent of 32 degrees. So in this case, we could use these numbers 5 and 8, or we could use the calculator. Let's see if these match up to be the same thing. So, oh, I lost my calculator. Let me reopen it. So sorry. Here it is again. And I'm gonna make it way smaller. There we go. So tangent 32 is 0.6248. Okay, 0.6248. And let's try if we type in the same thing, but instead the right side is 5/8. 0.625. So do you see how close they are? They're very close. And this one is the exact answer. Our 5/8 is the approximate answer here. Let's try another. With this same picture at mind, it says scientific calculators have this button, which we're starting to learn. And we know how to use the tangent button now. We've done a few of them. So this is really just a mention on the tangent button. And I want to remind you that you can use this scientific calculator on Decimals, which is free online. You can also use it on your TI-84. On here, you'll see it's above the 9. It's the tangent button. So let me give you a little look there. It's the 9, above the 9. And the one other thing I wanted to mention is you might be getting some weird answers if you're in the wrong mode. So let me pause for a moment and mention how to change mode. So you'll notice there is a mode button on most calculators. If you hit that, you want to make sure that you're on degree mode. So I've got that one flashing in the time being here. So I'm really hoping this shows up well, but you should be on degree mode. If you're in radian, weird things will happen with your answers. And that's really all I'm going to say about that. If you're wondering what in the heck radians are, it's basically a different way of measuring angles. So like, so to speak, we're talking centimeters, and radian is like all of a sudden talking about miles. Like they're different units of measurement. Okay, so moving forward, let's try to use this tangent ratio a little bit more. On this problem, I can see that my reference angle will be 66, and I need to label my sides. So across from 66 is my opposite. I'll use O for opposite. Next to it is adjacent, and then the one across from the right angle is hypotenuse. Tangent of 66, whoa, 66, not 60, nice try. Tangent of 66 is equal to opposite over adjacent. Opposite in this case is x, and adjacent is 15. So I've got tangent of 66 equals x over 15. I want to solve for x, so let's get rid of the 15 on bottom by multiplying both sides by it. That way it's gone from here, and I've got x by itself equals 15 tangent 66. We can calculate that. Clear. 15 tangent 66. It says it's about 33.7, we'll say. So let's round and say 33.7. There's my answer for this one. Another one. Let's label our sides. I've got across from the right angle is hypotenuse, across from my reference angle is opposite, and the last one adjacent next to 31. We're using 31, so tangent of 31 is equal to opposite over adjacent, so x over 10. And I want to solve for x, so let's multiply each side by 10. So the 10s will cancel, and I've got x by itself, so 10 times tangent 31. Let me clear this out again. 10 tangent 31 is 6.00. I could round this just to 6 because the 2 zeros won't do much for me. So x is approximately 6. Let's try another. I've got my reference angle of 66. Across from it is opposite, next to it is adjacent, and across from the right angle is hypotenuse. Let's set up our tangent of 66 equals, instead of opposite over adjacent, we'll put 14 over x. Now in this one, x is on the denominator, which is a little bit funny. So let's do something weird to get it out of the denominator, and let's multiply both sides by x. So it's no longer on a denominator, and we've got x times tangent 66 equals 14. I want x by itself, so let's actually just divide both sides by tangent 66. We know that's a number anyway, so we can divide by it. So I've got x by itself on the left, and on the right, I'm going to type this in, 14 over tangent 66. 14 over, meaning divide, tangent 66. If you're using a different calculator for this, you're going to want to type it in this way, 14 divided by, which I think it shows as a slash. Let me write it like this. So you'll want to put a parentheses, and then it'll open up parentheses and you'll have to close both. So this is how it will look like in your calculator. But anyways, on the scientific one, on Desmos, it looks really nice. You should get about 6.2 for x. My last one here, we have got to label sides across from the right angle hypotenuse, across from our reference angle opposite, and the last one adjacent. Let's use tangent of 43. Instead of opposite over adjacent, we've got 12 over x. And let's see what we can do to solve for x. I'm going to multiply both sides by it so they cancel. And then I want to get rid of the tangent 43, so I'm going to divide both sides by it. So x equals 12 over tangent 43, which is 12 over tangent 43. Okay, 12 divided by tangent 43. About 12.9, I'm rounding up because of the 6, so about 12.9. All right, that's all I've got for us today. As a refresher, what we're really doing here has 2 big steps. Let me write them now. Number 1 is you're going to label sides, and I mean hypotenuse, opposite, and adjacent. Number 2 is you're going to set up an equation where tangent of your reference angle, so something is in this theta spot, equals whatever the opposite side was over the adjacent side. You then can solve in one of 2 ways, either just by multiplying by the number on bottom and then typing in your calculator, or if it's in this situation where x is on the denominator, there is a small shortcut I want to mention, where tangent of theta, if you have a number, which we'll just say you had some number, I don't know, we'll do 5, over x, you can actually switch the places of these 2 things. So what I mean is I can switch the places of this and this. So you get x equals 5 over tangent of your angle. So notice that's what happened here. We started with this, and then we got this as our next step. So these switched places. That's a shortcut for you. But these are our 2 steps to kind of wrap things up. And we're going to continue to use the tangent button as we go. If you have any questions, please feel free to let me know. And I will see you next time. Bye, guys.